Okay, sequences. Well, a sequence is a list of numbers. For example, 1, 1, 2, 3, 5, 8, comma. Entonces you indicate that means que this continues forever. Entonces, for example, the notation that we are using is, this guy is the first one, it's called ACE1. This is the second, ACE2, and so on. ACE3, ACE4. In general, we have A sub m, que es the term que corresponde with the m position. The next is identify the explicit formula for the sequence in both directions. For example, I give you the formula. This is the typical notation, no? The specification 1, function of the m, and n vary from 1 to infinity. And this is equivalent to evaluate 1, 2, 3, 4, 5 natural number. Then the sequence is equivalent to say 2, 4, 6, 8, 10, and continue using the same formula, explicit formula. Another example. Suppose 2n minus 1 from n1 to infinity. This is exactly the same, but minus 1, entonces 1, 3, 5, 7, 9. So, by the way, this is the even number, and this is odd numbers. Another interesting example is, suppose this, negative 1 to the n power from n equal 1 to infinity. Entonces, 1 is negative 1 to the 1 is negative 1, this 2 is positive 1, negative 1, positive 1, and this continues. This is alternating sequence to change the sign. Okay, the next is in opposite direction. I have the sequence totally expand, and you try to identification the explicit formula. It's obvious that this is exponential, so it's like 2 to the m, the base is 2, from n equal 1 is 2 to infinity. Suppose another is similar 1, 3, 7, 15, 31. Well, it's exactly the same except it's minus 1. So the formula is 2 to the n minus 1 from n equal 1 to infinity. Suppose this is interesting. 1 over 3, comma 2 over 5, comma 3 over 7, 4 over 9, and 5 over 11. Okay, this is easy because in the top we have a natural number, this is just m. In the bottom we have the odd number, because the odd number is 2n plus 1. From n equal 1 to infinity. Okay, another example is, for example, 1, 4, 9, 16, 25, 36. It's obvious that the explicit formula is, you see that this number always raised to the second power, so a square. N squared from n equal 1 to infinity. Okay, easy. Okay, recursive sequence. It's a sequence we cannot find the A sub n explicit formula. Well, we can, but it's very complicated, or sometimes it's impossible. However, it's easier to compute the recursive formula. Recursive formula. Que no es explicit formula, it's recursive formula. So in this case, the recursive formula is A sub n plus 2 is equal to A sub n plus 1 plus A sub n. Let me try to interpretation this. The idea is to find any, for example, to adding this and this together, 1 plus 1. The two previous number of the sequence you adding according to this formula, no? 1 plus 1 is 2. Next one is 1 plus 2 is 3. Okay, this is the recursive formula, and this is the recursive sequences we studied, of course, and you remember.